Greetings everyone and welcome to SpaceWeek Live for Sunday, April 25th, 2021. Lots going on last week and this week, so let's get started. I can pull my notes up. Let's see. So, hey, look at this. It's not quite Bennu Cam, but we've got a small cat in the background there underneath the yin-yang planets. All right. So, last Monday, the solar-powered extraterrestrial helicopter Ingenuity flew for the first time on Mars. It reached a height of 3 meters or 10 feet and hovered for about 30 seconds. Here's a little video that I put together. Bear in mind that due to the limited frame rate of Perseverance's mast camera, the video is essentially a time-lapse. Ingenuity was in flight for a total of 39.1 seconds. And in its ceaseless attempts to troll me, my operating system has switched audio configurations on me. Alright, let's see. Nope. One sec, let me fix this. It'll take 2 seconds. Opera. You cheeky bugger. Alright, let's try this again. Shall we? Very cool indeed. Then 3 days later, it did it again. Um, this time, it reached a height of 5 meters or 16 feet, hovered for a bit, tilted 5 degrees, and moved sideways by 2 meters or 7 feet. No inspiring audio music here, but so that was a video we got from JPL. I'm not seeing the tilt and translate, but it takes time for them to get all the video. I mean, they don't receive a video; they receive images from Perseverance, and they have to stitch them together. But yeah, and then this very morning, Ingenuity flew for a third time, farther and faster than ever. It ascended to about the same height as the second flight. Then it tilted its rotors and zipped 50 meters or 164 feet downrange, about half the length of a football field, reaching a top speed of 2 meters per second or 6.6 feet per second. This color photo was taken by Ingenuity from a height of 5.2 meters or 17 feet, showing the rover's tracks in the rusty regolith dust. The video of Ingenuity's 80-second flight will be received by NASA JPL in the coming days. A short distance away, back on the Martian surface, the MOXIE instrument aboard the Perseverance rover has successfully manufactured oxygen on Mars. By drawing in the thin carbon dioxide atmosphere of Mars and baking it at 1470 degrees Fahrenheit, or 800 Celsius, MOXIE is able to split off one of the oxygen atoms from the CO2 molecules and then emit CO, or carbon monoxide, back into the atmosphere. Over a period of 55 minutes, MOXIE was able to generate 5.37 grams of pure oxygen. A rocket launching 4 crew members from the surface of Mars would need about 25 metric tons of oxygen, 4,655,000 times what MOXIE produced. It would take MOXIE more than 480 years to produce 25 metric tons. Like Ingenuity, though, MOXIE is just a proof of concept, a technology demonstration not intended to do any real work, but rather to show that a thing can be done. We can fly on Mars. We can generate oxygen on Mars. A future, more industrial-scale version of MOXIE could be delivered to the Red Planet, where it would churn out tons of oxygen for both spacecraft fuel and astronaut breathing. It would almost surely need to be powered by a large RTG, or multiple RTGs, radioisotope thermoelectric generators, like Perseverance uses, as solar just wouldn't provide enough wattage for large-scale intense heating. A point of scientific clarification: power is the rate at which energy is transferred, measured in watts. Energy is the total amount of work done, measured in joules. 1 watt equals 1 joule per second. Then on Friday, oh, hello. On Friday, here we go. Whoop. Then on Friday, that was funny. Then on Friday, the SpaceX Crew Dragon Endeavour launched the Crew-2 mission to the ISS with 4 astronauts aboard. Mission Commander Shane Kimbrough, pilot Megan MacArthur, and mission specialists Akihiko Hoshide from Japan and Thomas Pesquet from France. First of all, I guess let's check out the launch real quick.
T-minus 15 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Mission and liftoff. Godspeed, Endeavour and Crew-2.
Copy, 1 Alpha.
Endeavour launches once again. 4 astronauts from 3 countries on Crew-2, now making their way to the one and only International Space Station. The vehicle is pitching downrange.
So much thought and preparation goes into these missions. The Falcon 9 booster and the Crew Dragon capsule were both flight proven, both having carried humans to space previously. The booster was the same one used to launch the Crew-1 mission last November. It looked a little worse for wear after landing, but SpaceX fixed it up. Nice and shiny. And that's cheaper than building a new one. The Crew Dragon Endeavour was the same capsule that astronauts Bob Behnken and Doug Hurley flew during the Demo 2 mission 11 months ago. Ooh. Okay. Sorry. My computer's getting a little weird with the zooming. NASA astronaut Megan McArthur, Crew-2's pilot, is actually Bob Behnken's wife, as we've discussed before. She even sat in the same seat as her husband. There in the middle left. MacArthur flew to space once before on STS-125 aboard the Space Shuttle Atlantis in 2009. That was the last mission to repair the Hubble Space Telescope. She was actually the ascent and entry flight engineer and the lead robotics crew member. She stands, she holds the honor of being the last human to lay hands on the Hubble Space Telescope. She also has a PhD in, that's not her, she also has a PhD in oceanography. Here's a description of her graduate research courtesy of Wikipedia. Her research focused on determining geoacoustic models to describe very shallow water waveguides using measured transmission loss data in a genetic algorithm inversion technique. That totally makes sense. Astronauts truly are amongst the best of us. This is Mission Commander Shane Kimbrough's third time in space, in his third vehicle. He flew on Space Shuttle Endeavour during STS-126 in 2008, then on Soyuz MS-2 in 2016, and now on Shuttle Endeavour's namesake, Crew Dragon Endeavour for Crew-2. This Crew Dragon was named after the Space Shuttle because both Bob and Doug had flown on the Space Shuttle Endeavour. Let's see. Kimbrough has done 6 spacewalks, having spent a total of 39 hours floating outside the space station. He was also a full bird colonel in the Army, having flown Apache attack helicopters in the First Gulf War. Thomas Pesquet actually served with Kimbrough on the ISS, doing 2 EVAs together back in 2017. Those balls remind me of these, like, what were they called? Kinects or something? These toys I had as a kid that had these little balls with, they look like Christmas ornaments with little, like, connectors on the end of them. You'd connect them together. They had, like, gears and stuff inside. And you could make machines with them. They were pretty cool. Us 80s kids. Finally, Aki Hoshide also shares Kimbrough's privilege of having flown to space on 3 different vehicles. Space Shuttle Discovery on STS-124 in 2008, then Soyuz TMA-5M in 2012, and I don't know what's with the mission designator there. It didn't have an MS designator, but I'm not sure why they changed that. And now Crew Dragon Endeavour. Now that the introductions are out of the way, okay, we saw the launch video already, but, and this is I said I was 95% prepared for this episode. This is what I did not have scripted for you, but I remember it quite well. About 8 hours into their flight up on Crew Dragon, they actually experienced a pretty dangerous situation, a close encounter, a relatively close encounter, with an unidentified piece of orbital debris. Now, during the broadcast, they did not specify the size or the close approach distance of the object, or what it was from, but they basically had to take emergency measures or precautionary measures because of the close approach. What happened was Mission Control, SpaceX Mission Control, notified the crew of the approaching object about 20 minutes beforehand, and they had to, ooh, ding, they had to, basically they were floating around the cabin at that point, but they had to put on their suits, put blankets up, protective blankets up over the windows of the Crew Dragon craft, and then get back in their seats in preparation for the potentiality that they may have to pressurize their suits in the event of a pressure loss event if the object had actually impacted Crew Dragon. In the end, it did not impact. It passed a little farther away than was expected, but Mission Control continued monitoring the object. Or I'm not actually sure who exactly was monitoring the object, whether it was NORAD or some other, or a NASA, radar monitoring facility. But whoever was keeping track of the object continued to follow it to assess its potential impact on the mission and future satellite encounters. But here's the first few seconds of the video of that encounter.
Dragon SpaceX for possible conjunction.
Yes, Sarah, go ahead.
For awareness, we have identified a late-breaking possible conjunction with a fairly close miss distance to Dragon. As such, we do need you to immediately proceed with suit donning and securing yourselves in seats. We will be erring on the side of caution to get you guys into a better configuration. The time of closest approach for this event is at 17:43.
Copy, Sarah. You want us in the suit for a possible close call? Okay, we're getting in the suit, and we copy all.
So they passed the object with no conjunction of the Crew Dragon with that object, and maintained professionalism at all times, as is entirely expected. They continued on their journey, and many hours later they docked successfully with the ISS. And I don't actually have the video of their approach queued up, but they got some beautiful views of the ISS on approach. The camera on Crew Dragon's docking port is much better than on Soyuz. Let's see. Then that was that was it for last week. Some big events, but yeah. Looking ahead to this week. Oh, I'm hiding a couple things there. Looking ahead to this week, tonight, Sunday, April 25th at 6:14 p.m. Eastern, 22:14 GMT, a Soyuz 2.1B with Fugate upper stage will launch 36 more OneWeb satellites into low Earth orbit from Vostochny Cosmodrome in eastern Russia. Then on Monday, April 26th at 4:46 p.m. Eastern, 20:46 GMT, a ULA Delta IV Heavy will launch the NROL-82 spy satellite into a polar orbit for the National Reconnaissance Office. The exact orbit isn't known, but it has been said that this will be going into a polar orbit so that it can get observational coverage of the entire world. Then on Tuesday, April 27th at 9:50 p.m. Eastern, 0150 GMT on the 28th, an Arianespace Vega will launch the Pleiades Neo 3 Earth observation satellite for Airbus, plus multiple rideshare payloads. This will be the first Vega launch since the failure of VV-17 last November. Wednesday, April 28th, in the very wee hour of 12:05 a.m. Eastern, 0405 GMT, a SpaceX Falcon 9 will launch the 25th batch of 60 Starlink satellites bringing the total number of Starlinks in orbit to 1,441 out of 12,000 plus projected. In related news, a few days ago, I got a very exciting email from the Starlink team letting me know that my installation kit is being prepared for shipment. Do I plan to try mounting the Starlink antenna in my Tesla Model 3 for mobile broadband internet? Darn Skippy. Yes, I do. No idea how that'll work if I'm mobile, but I've got to try. A few hours later on Wednesday, starting at 4:45 a.m. Eastern, 08:45 GMT, coverage begins for the departure of the SpaceX Crew-Dragon Resilience, with Crew-1 astronauts Mike Hopkins, Victor Glover, Soichi Noguchi, and Shannon Walker aboard. Undocking coverage starts 2 hours later, with splashdown in the Atlantic Ocean happening at 12:40 p.m. Eastern, 16:40 GMT. Even later on Wednesday, it's a busy day, at 11:18 p.m. Eastern, 03:18 GMT on the 29th, a Long March 5B will launch from Wenchang on the southern coast of China with Tianhe-1, the core module in the new Chinese Tiangong space station. There will probably be a live broadcast for this high-profile launch, which I'll bring to you right here on Raw Space. This week, let's see. Let me go full screen. This week we might see the SpaceX Starship SN-15 prototype launch. Currently there are TFRs for Tuesday and Wednesday, with at least one website predicting a flight on Friday. So stay tuned for more info on that. Fingers crossed that they can manage a flight without an explosion this time, either in the air or on the ground. That is quote-unquote it for this very busy week ahead of us. And I would like to take this time to thank and welcome our new channel members, Ai.WAu and Dennis Cruz XJW Victims Support. Thank you and welcome to new channel members. Also, members, put that in the chat for those of you who are interested in contributing to the channel. Now let me get to your questions, which have been expertly compiled by our very own Chris V. Thank you for your help. Geraldine Braun. Not so much a question, but wouldn't it be okay? Wouldn't it be not sure. I'm not sure I can say that, but yeah, that would be something. But they're not up there together, so 250 Mile High Club, maybe not. But yeah. Mark Desire, was that really its speed going up and down raw space? I presume he's referring to Ingenuity, yeah. No, that was accelerated because the... my hair's a mess. I don't have ADD at all. Squirrel. Yes, that was not its speed going up and down. That was accelerated because the Perseverance rover's Mastcam Z camera does not take 15 frame per second images or whatever, and so you could interpolate the frames and stretch it out to real time, but no, that video is sped up, so we don't get to see it in real time, not without some digital manipulation. Chris V himself is asking, wouldn't the rover landings, Curiosity, Perseverance, be controlled, powered flight? No, because rocket thrust does not constitute aeronautical flight. It's not like they have control surfaces. Well, they came down on parachutes, which a parachute is not controlled flight. You're simply falling slowly by using the air as resistance. But the retro thrusters would not constitute flight. They are I guess you can get pedantic or you can get what's the word? Anyway, semantic about this, but I don't think they count rocket thrust as having accomplished controlled powered flight, because with an airplane or a helicopter, you can go up, down, side to side. You can navigate to different locations. With a rocket, you go forward, basically. Whether it's up or out, you go forward, and that is it. So I guess you can say, a rocket can reach the same destination as, let's say, an airplane, but so it could reach the same location as an airplane, but you're not using aerodynamic surfaces to do it. You're using chemical propulsive thrust. And whereas an airplane or a helicopter actually uses the air to keep itself aloft, rather than using thrust. So it's like, is Pluto a planet? Is it a dwarf planet? It depends on your definitions. Slim Pickens, was the debris going in the same direction as Dragon? We don't know. At least we didn't know at the time of the broadcast. If there has been any additional information about the object they had a close encounter with, I have not seen it, but I've been pretty busy and I haven't really looked. I will do some looking, because a lot of people will be curious to know, for pretty much just idle curiosity or academic reasons. Obviously, this particular object is not going to be an issue for Crew-2, but it probably will have deorbited by the time they come back down. But it needs to be tracked for its potential impact on future missions and satellite intersections. Although there are not many, I don't know at what altitude Crew-2 was when they encountered the object. There aren't many satellites that orbit below the space station. So, because the space station's orbit is fairly low as far as orbiting objects, because the lower you get, the more air resistance you get from the very, very thin, stray oxygen atoms and so on that exist above Earth's atmosphere. And therefore, the shorter any satellite's lifespan will be, the lower it orbits. Slim Pickens, why can Soyuz launch and dock so much quicker than Dragon? This question comes up every time, and every time Crew Dragon launches, because the Soyuz can get to the station in minimum of about 3 hours, whereas the Crew Dragon launches that we've seen thus far have taken upwards of 30 hours, even 31 hours to reach their destination. Actually, I'm sorry. Let's see. 5:49 to 5, so 24 hours to reach the station. The live stream, the marathon live stream that NASA and SpaceX hosted, and I also brought to you here, was about 30 to 31 hours, but the flight itself was about 24. So that has to do with the orbital inclination of the space station as it passes over the direction of its pass over the Cape as Crew Dragon launches, as well as mission parameters and crew needs. For example, they wanted to make sure that the crew they wanted to make sure that the crew got in an 8-hour sleep cycle, and they had to work that, and so that involves, pre-sleep activities, post-sleep activities, and so they worked all that into their mission plan, and it just means that plus, if you were to have a 24-hour ascent to the space station in a Soyuz, oh my gosh, that would be miserable because you can't get out of your seat at all. You can't get out of your seat, you can't take off your flight suit, you can't use the restroom, you can't sleep very well, you know, because you're stuck in your seat, crammed in next to two other guys. Not always guys, but two other people. Additionally, the faster ascent requires more fuel, and so you're basically wasting fuel to get to the space station faster. The slower you can do things in space, the more fuel you will save, and that's money in your pocket, basically. So there are a few answers. I really should, though. I really should do some research on the many reasons why you know, the uphill flight to the space station differs so you know, vastly between Soyuz and Crew Dragon, because I'd like to understand it better myself. Always be curious. ABC, hey, there's your phrase for the day. I'm sure I did not just come up with that. It was probably in my subconscious somewhere and just bubbled up to the surface. Percolated, if you will. Geraldine Brown. How many rovers are there on Mars? Isn't one of them in hibernation? So there are currently 2 active rovers on Mars. I mean, the original was Sojourner, the Pathfinder Sojourner rover, back in 1997-ish, was it? And then the Mars Spirit and Opportunity rovers launched in 2003, I believe. Then there was the Curiosity rover. I forget when that launched, which is still active. Spirit and Opportunity are now defunct. They are no longer operational. They lost power. They were solar powered, and they lost you know, their ability to generate sufficient power to continue operations. And so now we have Curiosity and Perseverance still operating on Mars. Now, there's lots of landers on Mars, but those are the only rovers on Mars. I'm sorry. Yeah. Yes, those are the only rovers. I was trying to think of the Tianwen-1 mission from China involved an orbiter and a lander, but I don't think that's a rover. And if I'm wrong on that, please forgive me. I'm just trying to remember back to last July when it launched. I don't think Tianwen-1 is a rover. It's just a lander. But now they did have a rover on the moon, on the far side, in fact. Ken Jacob. Why does Starship take 5 months to get to Mars, but it takes 7 to 8 months? Well, the speed with which you... The most efficient, the most energy efficient means by which to get to between planets is a Hohmann transfer orbit, where you basically, as the planets orbit the sun, they're orbiting at different speeds. Actually, they're reversed. So this is, I can't make my fingers do that. The inner planet Earth orbits the sun more quickly than the outer planet Mars, and basically you cross between the two in an arc like this. So you leave Earth here, and you drift outwards toward Mars, and you intersect with Mars's orbit over here. That's an energy efficient method, but it's also fairly slow, you know. And exactly how long it takes depends on the alignment of Earth and Mars at the time, because, you know, orbits are elliptical, and Earth's orbit is slightly elliptical. Mars's orbit is slightly more elliptical, and you know, the exact distances between the planets is going to vary from one conjunction to the next, or from one, you know, launch window to the next. And additionally, the performance characteristics of your rocket, as well as the mass of the payload to be, you know, to the spacecraft to be carted out, you know, the mass of the lander, or the mass of the Mars probe, as well as the, you know, thrust of the rocket. They all factor in to determine how fast you can get between, the planets. Orbital mechanics are very not counterintuitive, but they're not entirely obvious to those of us who are used to operating gravity bound on the surface of a planet. We should all, we should all probably go out and get Kerbal Space Program and play it for a while, and we'd all have a better understanding of orbital mechanics, at least the basics. But in order to get to Mars faster, you're going to take your shallow approach and make it more steep, which means your approach angle to Mars is going to be more acute. You're going to need more deceleration when you reach Mars, and you're going to need a bigger rocket, or at least a more thrust to weight ratio on your rocket to payload, because you need to be traveling more quickly. But that need for deceleration is a big consideration at Mars, because you have two ways of decelerating. You have thrusters, and you have the atmosphere of Mars. And the atmosphere of Mars is very thin. It's only 1% the density of Earth's atmosphere. And so you have only a limited amount of deceleration that's available from the atmosphere of Mars. And so if you took a too steep an approach angle at too high a speed, you're not going to be able to slow down. Or you're going to have to do, instead of hitting Mars straight on, not straight on, but instead of heading directly to Mars and into the atmosphere, you're going to have to take like a series of long elliptical orbits around Mars. Like you're going to have to be captured by Mars's gravity in such a way that you take a series of long elliptical orbits that then bring you in closer and closer and closer until you can enter the Martian atmosphere at the appropriate velocity and angle. But that's going to take longer and maybe higher risk, because because you're performing more maneuvers basically. But in any case, a lot of factors involved in everything, all space operations. That's why they have rocket scientists work on this stuff. Matthias Hoppmann, static electricity and dust particles in the atmosphere. Will that be an issue regarding the longevity of the drones on Mars? Dust particles in the atmosphere. So even though the atmosphere of Mars is very thin, the regolith dust that we saw earlier in that photo from Ingenuity is very, very fine. It's a very fine dust because it's regolith. It's pounded up, surface material of Mars, kind of like the regolith on the moon. So it's like a fine powder, and it gets on everything. And because it's very fine powder, it also gets blown around by the wind. And there's plenty of wind on Mars. It's just a very thin wind, I guess you could say. But yes, the Martian atmosphere is very dusty, and it deposits dust on everything, including the solar panels of the solar-powered rovers, Spirit and Opportunity, which resulted in their, eventual demise. After the big Martian dust storm a couple of years ago, Opportunity lost. What happened was it lost. It couldn't get enough energy from its solar panels to keep itself warm during the Martian nights. Because Martian night is quite cold, negative 100 and something degrees or whatever. So, because it couldn't keep itself warm, it couldn't wake itself up. And because it couldn't wake itself up, it couldn't get more energy to, keep on going. So it's not exactly that the solar panels were covered with so much dust that that they couldn't wake the craft up again. It's that the craft basically froze to death Opportunity basically froze to death because of the atmosphere was so choked with dust during that global dust storm that it couldn't get any power. As far as static electricity, I don't know how much static electricity there is in the Martian atmosphere. Now, you know, the movement of bazillions of dust particles in the atmosphere is going to generate static electricity, but it's unclear how much, whether that's a dangerous factor or whether that's, you know, a problem for the rovers. I mean, the rovers are designed for, you know, traversing the interplanetary void, so they're pretty robust, and static is not, you know, I don't think there are any bolts of lightning that are going to be striking, you know, the rovers on Mars. I've never heard of lightning on Mars, but it's definitely something that JPL has considered, but not being a member of JPL, I couldn't say exactly what those considerations were. But good question in any case. Abhishek Saini, how much the life of Perseverance rover? So Perseverance is designed for, what is it? I'd have to go to the website. If you go to, what is it? No, let's look it up. LLII, let's look it up. Let's see. Oh, this is zoomed. All right. Spacecraft rover. Loading 3D rover. Still loading. Okay. Body, brains, camera, mic. Oh, hello. Wow, you're slow. I don't need to know about the... okay. Communications, markings, power, body. Main job, structure. Let's see. So, Perseverance, design, lifetime. Well, the RTG lasts for 14 years. That's the battery used on Perseverance and Curiosity, which Perseverance is basically very similar to. Launch date. Meow. History, design. Lifetime? No. All right, fine. Whatever. So I can't easily find the number. It's around. It's probably even on that page. But it's designed for at least 3 months, maybe 12 months Earth time. And but it's probably going to last for much longer than that. And unlike Spirit and Opportunity, it does not need solar power to keep itself warm. It's powered by an RTG, one of those radioisotope thermoelectric generators I mentioned, basically a nuclear battery. It's not an active nuclear. It's not a nuclear reactor. It uses plutonium. It uses the radioactive decay of plutonium to create heat, which creates electricity. And Benu's up on top of a tote box, just out of frame over the... Oh God, I can't do that. I'm not a weather person. Over there. Not a weatherman, so I can't figure out where my finger should go backwards in midair. Okay, Mars 2020 mission slated to last roughly 2 years. Thank you, Chris V, for that link. So, let's see. Any other questions? But the oh yeah, so it's slated to go on for 2 years. We'll probably go on for many more than that. But the RTG will last about 14 years. And the RTG generates progressively less power over time. So the more time goes by, the less power it generates. And MOXIE, for example, the oxygen generating instrument on the rover, consumes a large amount of power. And yeah, so they're probably going to get the MOXIE experiments out of the way as early as possible in the mission, because later on in the mission they're not going to have as much power available from the from the RTG. All right. Mark Desire asking if I am settled now in my new house. I mean, the settling process is going to take a few years, probably. I mean, in my old house, I had, boxes left over from like 2 moves prior, many, many years before. So you never really get fully settled. But I've made progress. I have my TV, mounted, my speakers hung on or put in their whatever places. I've got, yesterday, in fact, I put up a cable raceway to route the home theater cables up to the TV in a more elegant fashion than just having them draped down the wall. And I have the raceways for the speaker wire that are going to go like all the way up and around the room to where the surround speakers are on the way. They're going to, once they get here, I've got to, take on that project. But we still have some furniture we need to get. We still need a second chair in there. I still need a kitchen table, a small one. We have the chairs. We still need the table. But yeah, getting more settled. I still have some food in boxes that I'm not quite sure where to put it because our pantry is much smaller than in the old house. I also got these motion-activated LED magnetic lights for the closets, so that when you open the closet door and move around, it turns on automatically. Because for some reason the closets in this house don't have lights, and I don't want to pay for an electrician to wire them. So, but all right. People discussing RTGs. Now, whether or not an RTG is referred to as a reactor is kind of a matter of semantics, but it's not like a nuclear power plant. It's not the same thing at all. You're not undergoing nuclear fission, or it's just the natural radioactive decay of plutonium or whatever substance the RTG uses, and that generates heat. So let's see. So the like, if you remember the movie The Martian, when Mark Watney used they had the RTG buried, and he had to go out and retrieve it to keep himself warm in the rover or the vehicle. That was Hollywood excess. The RTG is not an unsafe thing to be near. The radiation is contained. That's why it's generating heat, because it's containing that radiation. But it will keep you warm. All right. So, all right. It looks like that's going to do it for this week. Thank you all for coming. We have a big week coming up, so make sure to tune in for all those live streams right here on Raw Space. And until next time, take care, keep it raw, and bye-bye.